we're at our last lab. So you've watched me, or actually we've introduced kind of the corrosion lab and what was going to be done. We've seen the video of how the corrosion lab experiment was to be conducted, and now we're finally getting into the kind of the data analysis. So let's go ahead and let's look at the data for our corrosion lab. So let's download it. Let's extract it here. Let's get a peek. All right. So I want to extract this data. I'm going to extract it on my desktop, and I want to create a new folder in order to do so. So I'm going to do corrosion. Oh, actually, I'm going to get out of the mechanics folder. I want to create like an inception folder. Corrosion S21. So do this, click on that, extract, and here we go. So these are all of my corrosion data files. So let's go ahead and let's open up our notebook. And so let's kind of put all these values in. So these are all of my data files. So let's go ahead and let's look at the first one, for example. So, okay, we see we import this data, and again, whenever you have curly brackets, we want to get rid of that, and let's kind of flatten these values. So we are going to flatten the values. So we see here that for this value, remember, what was our experimental setup? So let's kind of take a peek back at our corrosion lab. So in our experimental setup, we had our cathode was, or again, what we designated as the cathode was always going to be copper. And so for AG, we set that up as our negative electron. So if electrons are flowing from our negative terminal to positive terminal, we should expect a positive voltage. But we see here that AG silver versus copper, it's actually flowing, it's negative voltage. So that means it's flowing in the opposite direction. So actually, AG is our real cathode, and copper is our anode material. Well, let's go and look at our good old friend. We never should have left it behind. Always have a good periodic table at your disposal. So let's look at silver, for example. And let's look at, we're going to be looking at our electronegativity values all the way back into lecture 1. See, you never forget actually things that happen in this class. Let's go here. My pen is giving me a little bit of an issue right now. But anyways, we can look at this right here. So electronegativities. So let's take a peek. That's going to be our second column right here. So let's look for AG. So where is my silver? Here it is. So 1.93. Let's actually erase that right here. So 1.93 right there. What about copper? 1.9. So makes sense. The other one has a higher electronegativity, so we that kind of makes sense in our book. What about aluminum? So let's go to the second data file. Okay, that seems like it's moving in the opposite direction, or in kind of the right direction. 1.61 makes sense. Copper, more electronegative, wants to pull away with those electrons. So we need to now kind of look at this data, and we're going to basically calculate means. So you can use this kind of nifty code which kind of sorts everything, and then you can now calculate the means. So if I do RDAT, I could do RDAT of 1. So the first file, silver, so I could do the mean. So what is the mean of this? And I could do a table of all the means. And then we could kind of rank our electronegativity ranking chart and then make that, kind of essentially a table similar to what's kind of seen in our notebook. So on from length to RDAT. So you can now see these are all of the means of all of our kind of multiple experiments here. So that would give you your mean data. If you want to create like a bar chart, we want to, again, we want to calculate error bars. So we're going to use standard error in this class. So that's just going to be the standard deviation of the RDAT divided by square root of length of RDAT. So square root of the number of samples. So you see, error is pretty small. Again, you can kind of calculate that. Those are just standard error. So standard deviation divided by square root of the number of samples. So we treat each of these measurements as a distinct sample. So you have your means, your standard deviation, your errors, and so now you can kind of figure out, okay, which one's corroding, which one's shrinking, or which one's, we should expect gold, which is our, let's see, 1, 2, 3. So let's look at our third mean here. So we look at that. That seems to be negative. So again, seems like this experiment was done kind of correctly. So you want to kind of create, again, describe which one's corroding, which one's not corroding, which one is the real cathode, which is the real anode material. You can kind of create an electronegativity chart as well to kind of compare those. So there's lots of kind of options to kind of communicate your kind of memo. So again, what I'm talking about here is let's go ahead, let's look. So you can kind of rank one of these, kind of create these, what's our potential essentially, and you can kind of calculate the work that's done as well. So write an excellent memo. Remember, 4 pages only, so it should be a little bit of a fun, kind of make a prompt and describe kind of the scenario that you're working with. But that's it. So I will see you all in future classes. So congratulations, this is the last lab for Engineering 45, and have a great rest of your semester. I'll see you in the next video. Thanks. Bye.